Data handling. Collecting data. Let us take an example. Rohan is assigned to find the most common mode of transport of the students in his class by his teacher. Now Rohan collects the information from all of his classmates. That means he is looking for the information to get some result. Here we have different modes of transport of all the students in the class. So Rohan has collected some information about the different modes of transport of his classmates. So the information collected is called data. Data is usually collected in the context of a situation that we want to study. By looking at this table, we can say most common mode of transport is a bicycle. But if the data is more, this kind of arrangement of information will be difficult to interpret quickly. Thus, we need to organize the data in a systematic manner, and then it can be interpreted accordingly. So we have the graphical representation of data. Sometimes data is represented graphically to give a clear idea of what it represents. Let us recall different types of graphs. The first one is a pictograph. It is a pictorial representation of data using symbols. Let us represent the above information in the form of a pictograph. Each picture represents the mode of transport of each student. In this pictograph, we can easily see that since more number of students are using the bicycle as the mode of transport, the common mode of transport of the students is bicycle. By walk, bicycle, car, bicycle, bus, car, by walk, bus, by walk, bicycle, bus, bicycle, bicycle. How many students are using the bus as a mode of transport? 3 students. Let us represent another data in a pictograph. The number of watches sold by a seller in the following month is given. The given data can be represented in pictograph as follows. The next type of graph is a bar graph. Bar graph is a display of information using bars of uniform width, their heights being proportional to the respective values. Let us consider a bar graph representing the number of students interested in following sports. Observe that the bars are of equal width with equal gaps in between. The height of the bar represents the number of students for each sport. How many students like basketball? Yes, 6 students like basketball. How many students like soccer? 9. More number of students like soccer in the given data. So far, we have represented only one data in the graph. Can we represent 2 sets of data in a same graph simultaneously? Yes, we use double bar graphs for such representation. A double bar graph is a bar graph showing 2 sets of data simultaneously. It is useful for the comparison of the data. Now we have a double bar graph which represents the number of boys and girls that are interested in following sports. Yellow bars represent the number of girls interested in the given sports, and red bars represent the number of boys interested in the given sports. We can compare the favorite sports between girls and boys using this double bar graph. By looking at the graph, Who is more interested in soccer between girls and boys? Girls are more interested in soccer. Double bar graphs are used to compare the two sets of data easily. Organizing data. A competition is held in a college for the annual day function. The teacher wants to know in which of the competitions the students are interested. The teacher collects the name of competitions given by all the students roughly. Here the information is in unorganized manner. Usually, data available to us is in an unorganized form called raw data. Now, by looking at this raw data, can you tell me in which of the competitions students are participating more? It is not easy to answer the question looking at the choices written haphazardly. As we discussed earlier, if the data is in unorganized form, the interpretation will be difficult. So we need to organize the data in a systematic manner to draw meaningful inferences. Now let us learn how to organize the unorganized data. Let us arrange the data in a table using tally marks. Number of tallies before each competition gives the number of participants in each competition. The number of participants in each competition is known as frequency of that competition. Frequency gives the number of times that a particular entry occurs. For example, frequency of the participants who take part in dancing competition is 5. So this table is known as frequency distribution table as it gives the number of times the entry occurs. Now let us make a frequency distribution table for the following raw data, where we used to find the most common mode of transport of the students in a class. Here we have the frequency distribution table for the above raw data. Let us consider a raw data which represents the marks obtained by 59 students of 7th class. Let us make a frequency distribution table for this raw data. Can we easily make the frequency distribution table for this raw data? Observe that the data is too long and each entry is repeating several times. So the frequency distribution table will be too long. So for convenience, we group the entire data into intervals, which is called grouping the data. We make groups of observations, say 0 to 10, 10 to 20, and so on, and obtain a frequency distribution of the number of observations falling in each group. Thus we get the frequency distribution table for the above data. Since the data is to be grouped, this distribution is known as grouped frequency distribution. Now looking at the table, can you tell me how many students scored between 40 and 50? Yes, 6 students. Using grouped frequency distribution, it is easy to interpret the data even though the data is too long. Each of the groups 0 to 10, 10 to 20, and so on is called a class interval. Let us consider a class interval 10 to 20. 10 is the lower limit and 20 is the upper limit. Similarly, for the other intervals as well. You can observe that the difference between the lower and upper limit in each of the intervals is constant, which is 10 in this case. The difference between the lower and the upper limit in each of the intervals is called as width or size of the class interval, or simply called as class width. Observe that 10 occurs in both the intervals, 0 to 10 and 10 to 20. So 10 belongs to the higher class, which is 10 to 20. So note that while writing the tallies, the common observation will belong to the higher class. Summary. Types of graphs: pictograph, bar graph, double bar graph. The information collected is called data. Usually, data available to us is in an unorganized form called raw data. In order to draw meaningful inferences from any data, we need to organize the data systematically. Frequency gives us the number of times that a particular entry occurs. Raw data can be grouped and presented systematically through grouped frequency distribution. In a frequency distribution table, the difference between the lower and the upper limit in each of the intervals is called as width or size of the class interval.